In this video, we're going to introduce Chapter 5, which is all about exponents and polynomials. Section 5.1 deals specifically with just exponents. We have looked at exponents when we looked at the order of operations, so we're going to do a quick review and then we're going to get to multiple rules of exponents. And so I have this example here, x to the 5th power. And when we first started looking at exponents, we said that, hey, exponents is another way to shorten what we have to write when we multiply the same number a certain number of times, right? So x to the 5th power is x times x times x times x times x, right? So it's multiplying x 5 times. Remember, we call x the base, and we call the 5 the exponent. And remember, another word for exponent was power. So we can say x with an exponent of 5 or x to the 5th power. And so that's our review of an exponent. Of course, we can simplify when we're having numbers, but if we have variables, we'll pretty much always leave it as x to the 5th power instead of writing it out in this long way here. All right, but first, I want to look at what we call the product rule. And the product rule, it says for any integers m and n, remember your integers are your numbers, your whole numbers and their opposites. It says, and for any base x, x to the m times x to the n equals some number. Now, for us to figure out what that is, I'm going to look at this example here. I have x squared times x cubed, right? If we don't know this rule of exponents, what we normally do to simplify this is to multiply x times x, that comes from the x cubed, and then we multiply it by x times x times x, that comes from x cubed, right? I'm sorry, I might have said squared before, right? But x squared times x cubed is just x multiplied 5 times, and that result is x to the 5th power, because I have 5 x's multiplied together there. All right, notice the 5 is the same thing as this 2 right here, plus that 3. And so as long as our bases are the same and we're doing a multiplication, if we want to simplify, all we have to do is add our exponents. So x to the m times x to the n is x to the m plus n. Add those exponents together. All right. And so if we look at these examples here, it says to simplify, I have 3 to the 3rd power times 3 to the 2nd power times 3, right? Notice that that is a 3 to the 1st power here, right? And so if I want to simplify, this is going to be 3 raised to the 3 plus 2 plus 1. That's a 2 there. And 3 plus 2 plus 1 is 6. And if we simplify further, 3 to the 6th power is 729. All right, so 3 cubed times 3 squared times 3, using that product rule, will give us 729. In part B, we have a to the 6th, b to the 5th, and we're going to multiply that by a to the 9th times b to the 5th. All right, now notice that we have these parentheses here, right? But inside the parentheses here, I have multiplication. I have multiplication between that parentheses, and inside the parentheses here, I have multiplication. All that means is that all I have to do is multiply these things together. The order really doesn't matter when I have all multiplication. So I really can write this as a to the 6th times a to the 9th times b to the 5th times b to the 5th. And now I see that multiplication when my bases are the same, and so all I have to do is add my exponents. So that'll be a to the 6 plus 9 times b to the 5 plus 5. Of course, 6 plus 9 is 15, and 5 plus 5 is 10. And so using the product rule, we can simplify until we have a single base. You see your single base a to one single exponent, and here my b is to one single exponent as well. That's how I know when I've completely simplified. Our next rule is called our power rule. It says for any integers m and m, and for any base x, x to the m to the n power. Notice that the x to the m is in the parentheses there, and it's raised to an nth power on the outside. Let's see what happens when we do that by looking at this example here. Well, this 3 exponent out here tells us to do x squared times x squared times x squared. And of course, we already know the product rule that says that all I have to do now is to add these exponents together since my bases are the same. And so if I do this 2 plus that 2 plus that 2 right there, I get 6. So this is going to be x to the 6th power. And therefore, if I look at these exponents here, how am I going to get 6 out of 2 and 3? I multiply them together. And so x to the m to the n is x to the m times n. All right. And so I have this example here, a to the 9th to the 11th. Well, that's going to be the same thing as a to the 9 times 11. And a to the 9 times 11 is a to the 99th. Okay. I can do the same thing over here. We have x to the 4th to the 6th power times x to the 5th squared. Well, if I want to simplify that, I want to multiply my exponents. I'll get x to the 24th times x to the 10th. And of course, we can use our product rule. 24 plus 10 is 34. The next rule we're going to look at is the power of a product rule. All right. It says for any integer n and for any bases x and y. Notice here I have x times y, it's in the parentheses, raised to the nth power. Let's look at this example here to see what is actually happening here. All right. When I see this squared here, it tells me to multiply whatever I'm squaring by itself, right? And so that's going to be a xy times xy. Of course, the order doesn't matter, right? It's all multiplication. So this is going to be an x times y times y. Of course, that's x squared times y squared. All right? And so if you look, this 2 as the exponent sort of got, and I don't want to use the distributive property, but it sort of got applied to each thing that's multiplied inside of this parentheses here. And so if I want to complete my rule here, x, y multiplied together and then raised to the nth power is going to be x to the nth power times y to the nth power. And so let's look at this example here. We have 3x to the 5th. That quantity is going to be raised to the 4th power. And so if I want to simplify that, well, I've got to do 3 to the 4th power times x to the 5th to the 4th power. Of course, 3 to the 4th power is 81. And now I have a power rule up here where I have to multiply those exponents. Now give us x to the 20th power. So we'll have 81 x to the 20th. Let's go to part B here. In part B, what I'm going to do is I'm going to apply that 3 as the exponent, which we see here, to every single thing multiplied here inside this parentheses. And I'm going to do the same thing for this exponent 2. Notice everything inside of that parentheses is multiplied together, right? And so this is going to equal 2 to the 3rd power, x to the 6th to the 3rd power, times y to the 5th to the 3rd power, right? And then I'm going to have a 3 squared, x to the 8th squared, y to the 10th squared. Now I'm going to worry about simplifying my exponents first. So I'm going to leave this 2 to the 3rd the same. But when I have this 6 and 3, if I multiply them together, I get 18. Y to the 15th times 3 squared, x to the 16th, y to the 20th. Okay, to continue, notice I have a 2 to the 3rd power, that's 8. I have here an x to the 18th and an x to the 16th. Right? So when I combine those together, I have to add those exponents. That's going to give me an x to the 34th power. Similarly, I have a y to the 15th and a y to the 20th. If I add those together, I'm going to get y to the 35th power. And 3 squared is 9. And that way, the only thing that I have to do to simplify is to multiply my 8 by my 9. That is 72. X to the 34th, y to the 35th. All right. Let's go to our next rule, which is called the quotient rule. It says that for any integers m and n, and for any base x, x to the m divided by x to the n. Let's see what's happening here. All right. When I see x to the 4th over x to the 3rd power, if I want to simplify, let's say that we don't know any rules here. I'm going to have 4 x's multiplied on the numerator and just 3 x's multiplied on the denominator. Now what's nice when everything is written as multiplication is the fact that when I divide something by itself, they cancel, right? So x and x cancel. X and x here cancel. and these pairs of x's cancel. That means I'm only left with x, and as you can see, I don't have to put a 1 as the exponent, but I'm just going to put it there for just to make a point here. And so if you notice here, I have a 4 and a 3, right? And so if I want to simplify without going through this entire step right here, the relationship between 4 and 3 and this 1 right here is that if I subtract 3 from 4, I'm going to get this 1 that's sitting right there. All right, and so that is my rule, right? So my quotient rule says that, hey, if I have my bases are the same and we're dividing, we subtract our exponent. So that's going to be x to the m minus n. All right, and so this is kind of different from or similar to the product rule, but instead of adding like we do in the product rule, we'll subtract the exponents. All right, let's look at some examples of this. All right, in this first example, we have n to the 35 over n to the 7th. Well, if I want to simplify that, since the bases are the same and it's all both n, I'm going to do n to the 35 minus 7. And n to the 35 minus 7 will be n to the 28th power. Okay. Our next example is this one here, 28 to the 10th, b to the 12th, c to the 15th, all over 5a squared, b to the 6th, c to the 9th. All right. With numbers like the 20 and the 5, those are what we're going to call coefficients, are numbers that are multiplied in those variable expressions there. We divide those just like we normally would, right? And so if I want to simplify this, 20 divided by 5 is 4, just as always. And all of my exponents of my variables, we have to subtract the denominator from the numerator, right? So I have a to the 10 minus 2, b to the 12 minus 6, and c to the 15 minus 9. Of course, we're going to simplify that completely. So I have 4a to the 8th, b to the 6th, c to the 6th. And that is completely simplified. Our next rule is our zero exponent rule, which we've already looked at. Any number raised to the 0 power except 0 equals 1. All right. And so if we look at these two examples here, I have 8 to the 0 power. Well, that's a number other than 0 raised to the 0 power, so it's equal to 1. And I also have negative 9 to the 0 power. Remember, if that negative is not in the parentheses, that means to do the opposite of 9 to the 0 power. And so the opposite of 9 to the 0 power would be a negative 1. Our next rule is our power of a quotient rule. If we look at that rule there, it says for any integer n and for any bases x and y, x over y to the n power. Let's figure out what that is using this example here. Remember, when I raise something to the 3rd power, I multiply it 3 times. So I get x over y times x over y times another x over y. Of course, we have fractions we're multiplying across. And so if you notice, the numbers that we're multiplying are the same. And so if I multiply 3 of them, I'm going to get an x cubed. Same thing happens in my denominator, y cubed. And so this basically is saying that, hey, if I have a division inside of the parentheses, then everything inside of that parentheses gets raised to that exponent. All right. And so x over y to the nth power is x to the nth power over y to the nth power. All right. And so we're going to look at 2 examples of applying this rule. I have 5 over x to the 4th power. That's going to be a 5 to the 4th power over x to the 4th power. Of course, when we have actual values to an exponent, we want to simplify those completely. And so 5 to the 4th power would be 625. And of course, we'll have our x to the 4th power. One more example. 10x to the 8th all over yz to the 7th, and all of that is going to be raised to the 6th power. Of course, this is my numerator is going to get raised to the 6th power, as well as my denominator is going to get raised to the 6th power. All right, now I see a power of a product rule. That means everything inside of each of those parentheses gets raised to the 6th power. So I'm going to have a 10 to the 6th power, x to the 8th to the 6th power, over y to the 6th power, times z to the 7th to the 6th power. Of course, 10 to the 6th power is 1 million. x to the a to the 6th power. Now that sets up a power rule. So I multiply the 8 and the 6, I get 48. So I get x to the 48th over y to the 6th. And z to the 7th is raised to the 6th power. Again, that's a power rule. So I multiply those exponents. That'll be z to the 42nd power. Okay? And that encompasses all the rules that we're going to study. Now we're going to get to what we call polynomials. All right? And these are examples of polynomials. As you can see, we have basically variables multiplied by numbers, and then they're added. Those variable expressions are either added or subtracted from each other. All right? So these are some examples of polynomials. And we're going to give a much better definition of a polynomial, but these are just 3 examples here. One thing that we want to do with these functions that have exponents in them is to evaluate them, all right? And we've heard this word evaluate from time to time, right? Evaluating functions means to substitute the value in for the variable and then simplify and making sure that you use the correct rules of exponents. And then you can always check yourself with a calculator, all right? And so in this example here, I say for f of x equals 6x squared, find f of -4. And so notice we are using function notation. If you look here, this -4 is in the place of x. And so what we're going to do to actually simplify or evaluate or find f of -4 is to put -4 in for x. So I'm going to have a 6 times -4 squared. All right, that's going to give us a 6. -4 squared is 16. And so we need to figure out what 6 times 16 is, and that is 96. Okay? And so this is just looking at a function and being able to evaluate it. You got to use the remember your order of operations, remember the rules of exponents, and you'll be okay with evaluating functions using the rules of exponents. We're going to look at one last example, and this is an application problem that involves evaluating functions. It says the number of feet traveled by a free-falling object in t seconds is given by the function f of t equals 16t squared. All right? All right, so notice t is the number of seconds, and f of t, which is what we're calling our function, represents the number of feet. All right, so always remember what represents what when you're reading a problem like this. In part A, it says, if a ball is dropped from the top of a building, how far will it travel or fall in 3 seconds? All right, so right here, when they give us this 3 seconds, they're giving us t here. And since we're trying to find out how far, we want to find f of t. All right, so finding f of t, well, they give us that t is 3. So all we have to do is plug in 3 for t into our function, and we'll evaluate that function. All right. Well, 3 squared is 9, so I get 16 times 9. And, of course, 16 times 9 is 144. And so how far will it drop? My units here will be feet, so my solution is 144 feet. Part B says, how far will a skydiver fall in 7 seconds? So again, they're giving us 7 seconds, they're giving us a t, and they're asking us to find f of t here, right? So f of 7, now that I know that my t is 7, let's plug in 7 for t. Of course, 7 squared is 49, and so I get 16 times 49. And of course, 16 times 49 is 784, and my units here will be feet. Okay? And this concludes our video on exponents and exponents.